first example, we have to convert 5 30 degrees to rectangular coordinates. And so you could use a polar graph if you want to use that polar graph paper, or you can just kind of sketch it out. So if I graph 5 30 degrees on the one that I have here, 30 degrees is right here, and I'll go out 1, 2, 3, 4, 5. So my point would be about right here. Okay, so something to keep in mind whenever you're doing this is that your axes on your polar graph paper, they're the same as the axes on your rectangular graph paper. So it's kind of like if I was going to draw this, each place that circle, each circle is just a point on the graph. So if I were to look at this as not as polar graph paper, but as just regular rectangular graph paper, what would you guys estimate that the coordinates of this point right here are? Boone, I've been told you're the master of estimating. You can guess the right answer to anything. So if you were just guessing right here at about what the coordinates would be, what would your x coordinate be about? Okay, let's try 4.4. This is just our guess right now, because it's definitely somewhere between 4 and 5, right? And then what do you want to guess for the y? 2.5. Let's see how close he is. All right, so that's going to be a relatively close guess, but we would like something a little better than a guess. So let's look at this. I know the length of that line I just drew right there is 5. Because that's the radius. From the origin to that point, that's the radius. And then I also know that this angle right here is 30 degrees. So I could make myself a right triangle right here. And if I make that right triangle, this right here would be my x coordinate, and this vertical part would be my y coordinate. This is a little bit like when we were doing vectors. We had a wind blowing at 5 miles per hour, 30 degrees north of south, or north of east here. What are the northward and eastward components? So it's a lot like that problem. So if I wanted to find, we'll say x first. In this triangle that I have here, in this right triangle, x is my adjacent side, and 5 is my hypotenuse. So adjacent and hypotenuse, I could use cosine. So cosine of 30 degrees would equal x over 5. And so I could multiply both sides by 5. And so whenever I do that, is it 4.33? Something that you get 4.33. Okay, so very close to the 4.4 estimate. And then so that's our x coordinate, and then for our y coordinate, this is the opposite side, so we're going to have opposite and hypotenuse. So sine of, let me see if I can make that quick doing that, of 30 30 degrees would be y over 5. Ugh, gosh, that's annoying. So I would multiply both sides by 5. And if I do 5 sine of 30 degrees, you get 2.5. So he got that one exactly right. He was pretty close. So 4.33 and 2.5. Those would be the rectangular coordinates. On your final exam, you get to use Desmos on the final exam. You guys had that last year on the Math 3 exam as well. So if you graph 4.33, Desmos will only graph it will only graph rectangular coordinates. You can't type polar coordinates in, I don't think. Anyway, let's try. Yeah, you can't type them in, but I can type in 4.33 2.5, and it'll graph that point. And I can go over here to the wrench, and if you click right here, it'll change the background to your polar background. And you can see, and you can actually, I guess we're in radians right now, I can change it to degrees, and you could see that it's at 30 degrees, and this would be 5 right here. So you can't graph the polar coordinates, but you can change the background to be a polar graph, so you can check to see if it looks like it's right. So when you see this on the final exam, and they almost always have a converting problem on the final exam, you can use this Desmos to help you on that also. Okay, let's do one more. Okay, we're going to convert -4, -pi/4 to rectangular coordinates. So this is a little bit trickier to graph because you've got -4, -pi/4. So pi/4 is right here, but we want -pi/4, which is right here. So right here is your -pi/4. And we are going to graph -4, -pi/4. So rather than going, let's say I'm going to highlight right here, this is -pi/4. Rather than going towards pi/4, we need to go away from pi/4. So we're going to think of that line continuing on through. So when we graph this, instead of going towards pi/4, we're going to go away from. So 1, 2, 3, 4 would be our point. And so if I draw in that line right there, I know it has a length of 4. You could label it -4 if you want, but 4 is better. And then if I know this angle right here was pi/4, then this angle right here has to be pi/4 as well. What is pi/4 in degrees? It's 45. You can use either. It doesn't matter. I just kind of like degrees better. I'm going to use degrees. But you can use radians if you want. Plus, I won't have to change the mode on my calculator. So if we're just kind of estimating here, what do you think, Boone? What's our guess? Okay. Y coordinate. Okay. So that's our guess right now. we're just guessing. It does appear to be probably about 3, or a little more for both of those. So we want to know the actual amount. So we're going to make ourselves a right triangle. Or it might be 2 something. So whenever we set this up, this is our y. The vertical side is always your y. The horizontal is your x. So this is the adjacent. This is hypotenuse. So cosine of 45. Oh, come on. Let's do this. Quit. Stop it. Okay. Is going to equal x over 4. So we'll just multiply both sides by 4. So x is going to equal 4 cosine of 45 and 2.828. And for the y, we'll say sine of 45. Or if you remember 45, 45, 90 rules, what do we know about x and y? They're the same. So we could set it up either way. So we'll get y is also 2.828. But please be careful with your coordinates here, because our triangle, everything's positive. But if we're looking, this is in the second quadrant, so my x coordinate has to be negative, because I'd go to the left 2.82. So negative 2.828, and then positive 2.828. And so that would be my rectangular coordinates. He was pretty close. Not quite as good on that one as the last. Okay.